This is a schematic that shows the various climate regions of the world. First off, we'll begin by looking at the tropical rainforest. And so to read this climate region schematic, we'll begin with the one that is the hottest and the wettest. And so the closer you are to the right-hand side, the bottom right-hand side, those are the hottest and wettest climate regions. The closer you are to the top left, those are the coldest and the driest. There are two key things to note about tropical rainforest climate. First off, there's minimal climate variability. In other words, the January and the July temperature, there's not that much difference. We know this because of several things we've already discussed in this course. First off, that consistent day length, that 12-hour day, 12-hour night that persists along the equator, and so you're going to get that consistent day length instead of what we have in Indianapolis. At one time of the year, we might only have 9 hours of daylight, and the other time we have 15. Another characteristic is that high sun angle and a high amount of insolation. So the subsolar point's always nearby, but also the sun angle is very close to 90 through much of the year. Finally, the ITCZ is located in this area throughout much of the year, and so that's going to bring a lot of precipitation from convergence, but also it's going to bring a lot of cloud cover, which once again is another reason why temperatures are consistent. As we talked about beforehand, clouds do a good job of moderating temperatures. Further, the other key characteristic is it's always moist and warm. And so some have said that if you want to find winter in the tropical rainforest, that's night. That's when the sun goes down, where it cools down a little bit. But once again, clouds do a good job of keeping in that solar radiation. Also, what we'll find along the tropical rainforest area is not only convergence, but a good amount of convectional thunderstorms that are also occurring at the same rate in this area. This here is what we call a climatograph. At the bottom are the various months of the year, starting with January and ending in December. That's what the J and the D indicate. On the right-hand side, that measures in parentheses degrees Fahrenheit. The purple horizontal line we see about 3/4 of the way up. That's a line showcasing temperature in the different months as we go from left to right, January to December. On the left-hand side, those are the measurements for precipitation in inches, and the big blue bars, those big blue bars are illustrating rainfall. And so the moral to the story is, as you'll note when we compare this climatograph to others, we have a whole lot of blue on this graph illustrating a whole lot of rain. That's pretty much throughout much of the year. Another thing you'll note is the blue line is pretty horizontal. You'll see a much bigger difference when we compare it to other climate regions. The Amazon rainforest is located here right along the equator. Just like this rainforest area, which is also found along the equator, right through Central Africa. Both are influenced by the Hadley cell. So once again, the Hadley cell, that low pressure is found along the equator, in which we get that dense rain belt occurring from that low pressure converging of warm and moist air that quickly rises, and then of course quickly goes from evaporation to condensation to precipitation. And we all know this from a previous video lecture. Here we have the Amazon River and the Amazon rainforest. I'll come back later in this semester and explain why this looks the way it does. We'll come back to explain a meandering river and how it forms. I know you're excited. The Amazon River, all I really want you to get out of this is the fact that look at all that green. Because as Kermit the Frog says, it ain't easy being green. So to have all that green on that previous image requires a ton of precipitation, but also a huge amount of solar energy. And that is, of course, going to be found there along the equator. One key characteristic as far as the vegetation type that you'd find in the tropical rainforest due to the conditions I already mentioned is the fact you have these leaves that are quite big, what we refer to as broadleaf. And these are real big evergreen leaves. They actually never really lose their leaves. Why are they so big? Why this here, the banana tree, why so big? So it can capture as much sunlight as possible.